All right, guys. Yesterday we cosine 3x. We expanded that, so it worked down to be rewritten in just terms of cosine x, right? It became something like I think it's like 4 cosine cubed x minus 3 cosine x, something like that. But regardless, the argument was just cosine x. Okay. Then we kind of took on the task of trying to use that to come up with cosine 5x. We went through everything, and I turned a negative 10 into negative 18 for some reason. And I also, at the same time, multiplied by a negative, and I didn't change the sign. Okay? If you were to watch the rest of the video, you guys left, and about 30 seconds later, I caught my error. And what happened is that we ended up with cosine of 5x being written, I believe it was 16 cosine to the 5th x minus 20 cosine cubed x plus 5 cosine x. Okay? And I think when we were doing it in class, maybe I had a negative 18, or I think I had a negative 12 at one point, so that thing was getting messed up. But if we graph that and we graph that, they should overlap. Okay? They should be the same function. Now, why is this beneficial? At some point, we might have this equation where we're trying to solve and see where those two things equate to one another, okay? And we're trying to do it without the use of a computer or a calculator or something like that. So what we would need to do is expand that left-hand side. So the left-hand side would turn into, obviously, that. The right-hand side would be that, right? Okay? Now, if I have something to the 5th or higher, or just squared or higher, I'm going to think factoring. So I'm going to move this cosine x over, and it becomes plus 4 cosine x equals 0, right? Now that looks messy, so this is what we do. We say u is equal to cosine x. You guys remember doing u substitution back in college algebra? Well, now if we do that here, we get 16u to the 5th minus 20u to the 3rd plus 4u equals 0. Bring out a u, we get 16u. We can probably bring out a 4u, can't we? 4u, we get then 4u to the 4th minus 5u squared plus 1, okay, equals 0. And now we would continue to factor that thing, and that looks like it's written in terms of a quadratic. It's to the 4th and then squared, right? So that middle term is twice as much as the first term's power. So that might be factorable. Using some other techniques, maybe the AC method, that kind of stuff. But what happens here, guys, is we take a trigonometric equation and we essentially convert it over to an algebraic equation. Okay? And we rely then on our algebraic skills of factoring. Maybe if we don't see that 4u comes out, maybe we start using like P over Q stuff. Or maybe when I look at the 4u to the 4th minus 5u squared plus 1, maybe don't see that factors real well. We maybe then rely on rational root theorem, P over Q. Just kind of go a little bit further. So let's say that, let's go u squared is equal to v. So this thing would look like 4u. Okay, then this would be 4v squared, right, minus 5v plus 1. So then we'd have 4u. Does this thing factor? Can I go 4 times 1 gives me 4, right? Okay, does negative 1 times negative 4 work? Can I rewrite this as 4v squared minus 4v minus 1v plus 1, I get 4u, and this would be, what, 4v, it's going to be v minus 1, and this is going to be v minus 1. Okay, so I know this is getting ugly, and I'm running out of room here, and you don't have to do this right now. We get 4u, then 4v minus 1, and v minus 1, right? That make sense, everybody? Remember what v was? It was u squared, so I get 4u times 4u squared minus 1 times u minus 1. Okay, so now I'd have, and this is all equal to 0, I'd have 4u equals 0. I'd have 4u squared minus 1 is equal to 0, and u minus 1 equal to 0, right? Can I solve all those for u? Be pretty easy to solve all those for u, right? U equals 0 here, u equals 1 there, so this would be 1/4. Take the square root of that, so this would be plus or minus 1/2 for u, right? But what was u? Cosine x, right? So then we're going to back substitute that cosine x and find out where cosine 5x and cosine x intersect. Did I mess something up? Oh, okay, so it's u squared minus 1. Yes, you're right. So it's u squared minus 1 there. So then it would be u is equal to plus or minus 1, right? So that's going to generate a couple extra answers. But that's the approach that this stuff would be useful for. Does that make sense? Now, that would be one of the most kind of involved, complex trigonometric equations that we mess around with. Okay? There's a lot of stuff going on there. But the hope is that you start to kind of see where this stuff's going. I think a lot of times mathematics is backwards in regards to we learn stuff, but we don't know where it's taking us, right? Okay? And so when we're learning things and we don't know where it's taking us, maybe we don't kind of buy into the processes and buy into the learning of that information until it's too late and we realize, oh, this stuff's pretty important, right? And we got to backtrack and say, okay, now I got to relearn that stuff that we're using here. I think that idea, that concept is an issue for a lot of math students, and it creates a lot of difficulties. I think it's why math is hard for a lot of people. Okay, that's kind of why math was hard for me in the times that it's been hard, because I don't recognize the usage of what I'm doing, so I don't really buy in. Does that make sense? But if we can see where this stuff's going to go, hopefully then maybe we take a little bit more serious here. All these identities that we're working with, all these formulas, the purpose of them is so that we can take and work with trigonometric equations. A good portion of the next 8 weeks is going to be just solving trigonometric equations. Okay, we'll get into other stuff. We'll talk about polar coordinates and vectors and all that kind of garbage. But a good portion of what we've got left over is how we manipulate trigonometric equations. Okay, so we got to build this stuff in order to do that. Okay, so the next thing I want to do is actually use the double angle formulas to kind of address these types of problems that you're maybe seeing in your homework. And I do have, there are currently 2 7-3 assignments open. The first one I want to be due tomorrow, which I don't know if you're going to be able to because there's some half angle stuff in there and we don't get too much of that today. So I might have to push that back. And the other one's due after the weekend. So I might end up having to push that one back depending on what we get through tomorrow. But there are 2 7-3s open. You should be able to do some problems out of both of them. But these here, I want to do them, but then I want to go back to, okay, what did we really do? Because I think formula-wise, you should all be able to evaluate these. But can we then explain what's going on, what we did, what our answers mean to us? Because if we can, that provides a whole other layer of understanding, okay? And it allows you ultimately to pretty much check all of your answers, okay? I told the last class we could take any fifth grader, because at about fifth grade you probably start talking about area and knowing what area is, right? And they probably have a little bit of an understanding of what slope is. Any fifth grader can do some calculus, okay? You can give them a calculator, you can give them the formulas, you say, okay, plug these numbers in, hit enter, and tell me what you get back. They can do the work in calculus class, okay? But they can't tell me what that work meant. And they can't give me the underlying reasons of why we went through that work. Does that make sense? Okay? I think anybody can take these formulas and plug stuff in, okay, and get results. But do you know what those results mean? All right? If you've ever been interested in taking stats, or if you're going to go into a field that asks you to take stats, okay? Stats is a math class, but you do very little math in it, okay? Let me rephrase it. You do very little calculation in it, okay, and arithmetic. Most time you get to a college stats class, there's going to be programs like Microsoft Excel or MathLab or something like that, okay, that you type your data into, and the computer runs the functions on the data, okay, and it spits back this one concise value at the end. Then the math that's involved in stats is you being able to explain what that one piece of value, or that one value, that one number tells you about that group of data that you came up with. Does that make sense? Okay, so that's what statistics is about. It's the logic of analyzing data and that kind of thing. It's not so much calculations, okay? Because the idea as we move through mathematics is, do you know why you're doing what you're doing, okay? So I want to make sure we kind of take time to look at these from a different, maybe a graphical perspective to gain that. Okay, so this question says sine of 2x. Let me make sure I'm recording here. I don't think I am. Yes. Awesome. All right. So sine of 2x, cosine of 2x, tangent 2x from the following information. They tell us cosine of x is 5/13, and it's in quadrant 1. Okay. I think the best thing for us, guys, is to initially draw a picture. You can do it without a picture, but there's some stuff here that you're going to want to, I think, write down and organize inside your picture. So x is some angle that's being traced out. Okay. And if I trace that out, obviously, so that would be x. Obviously, there's a circle here that is being part of, but we can always then take that terminal point that ray intersects our circle with and drop it down perpendicular to the x-axis and we get that triangle, right? Okay. So the relationship between the circle and the triangle is very important in regards to sine and cosine, for the fact that right now it's telling me cosine is 5/13 Okay, cosine is 5/13 in quadrant 1. So what does that make the sine? Okay, it makes that y value, Pythagorean theorem makes that y value 12, right? So the sine would be 12/13, right? Obviously, we're not, if it were just a unit circle, it would be 12. But because we're in a circle with a radius of 13, 12/13. Now, here's what we're being asked for. Can you use that information to find sine of 2x? Well, sine of 2x is 2 sine x cosine x, right? Okay. So I have 2 sine x, we just said was 12/13, right? Cosine x is 5/13. Can we evaluate that stuff? All right, so I evaluate that, so it gives me, they're all relatively prime on top and bottom, so 5, so it's 120 over 169. Okay, now, we'll come back, we'll do cosine 2x and tangent 2x, but I want to take a moment and look at what we just came up with. Okay, if we go to a circle with a radius of 13, so a circle with a radius of 13 is going to have this equation, equals 169, right? Okay, so we're talking that circle. We just came up with, or they told us the cosine was 5/13, right? So I could go over 5 up 13, and that would give me the triangle that we're interested in, right? Okay. Now what I'm going to do real quick, just to make sure that that's a perpendicular line, is actually do it this way. And that's the triangle they're telling us when they say cosine is 5/13, right? Okay? If I were to look at these distances, 5, 12, 13, exactly what we came up with by hand, right? Okay? Now, we can also use the algebra here. If this is 5/13, do you have the ability to find that angle right there? You would use what function? I want to find that angle. You'd use the inverses, right? It doesn't. I can go arc cosine. Okay, arc cosine of 5/13, and gives me that angle right there, right? Or I could go arc sine of 12/13, same angle, or arc tangent of 12/5, same angle, right? Okay, so it doesn't really matter which one I use, but right now then, I know, and you know, that that angle is 67.38. Okay? I don't want these other two here. That make sense to everybody? So if I were to double that, because that's what we're doing, right? We're taking a double angle, it'd be like 134, right? Okay? So let's do that. Let's go ahead and double that angle. So I'm going to take beta times 2. And that gives me that number right there. Okay? Epsilon, 134.76. Okay? Let's get this thing to trace out that angle. Let's go there to there, but now I want this thing to use epsilon. And now the angle that's tracing out, let's see here, the array. Intersect that with that. Let's go perpendicular from there to there. Okay, so what we just came, so we're going to 134.67 or 76, guys. We are tracing out. We're talking ultimately that angle there, correct? Okay, and it provides this terminal point over here on the unit circle. Well, not the unit circle, the circle with the radius of 13. And if I go straight down from that point, we get this triangle here, right? If I know something about that angle and that triangle, isn't that going to be the same thing for the purple angle of the 134.76 degrees? Okay, so let's look at that one there. Okay, and let's look at what these distances are of that orange triangle. If I find that distance there, and then that distance there, and now I'm going to have to move some stuff around here to get to the, there we go. This distance there, 13. Okay. So the 134.67 or 76 is that purple angle. If I ask what the cosine of 134.76 is, it spits back that number right there, correct? Okay. Well, let's look at what we get when we take cosine of this information here in this triangle. If I take cosine, it would be 9.15 divided by 13, right? So give me the same quantity. Does that make sense to everybody? The only thing that I'd have to pay attention to here is that yes, the sine of 2x is 120 over 169, but the cosine is going to be negative. So let's do, and I guess we'll get to the cosine here. I thought we did cosine first. Let's do the sine. So if I go sine of 134.76, it gives me 0.71. And now using the orange triangle, it's 9.23 divided by 13. That's obviously a positive number, and it's 0.71. Does that relationship kind of make sense of what we're doing here? Okay? So the sine of 2x formula is giving me everything I need to know about that purple angle from ultimately the angle that's in the blue triangle. Okay? And it allows us to, it's a formula that essentially bypasses all this work that we're doing in GeoGebra. Okay? And then think about your formulas. Whenever you do a formula, science, math, whatever class, it's a shortcut for some longer process, right? Okay? This is the logic in the longer process that formula is using. Okay? Now let's do, we know cosine now of, so this was the cosine here of 134. Let's see, based on the information we get, let's see if we get that 0.7 back to be negative when we do this. So let's go cosine of 2x. Okay? Now, you have options here. Remember the cosine formula, there are three of them, right? Three different versions. You can use cosine squared x minus sine squared x. You can use 2 cosine squared x minus 1, and you can use 1 minus 2 sine squared x. Okay? A lot of people get kind of hung up with these because they forget which ones, I mean, they're very similar, right, in nature. They forget which one's the cosine squared and which one's the sine squared. Just be careful with those. But based on the initial information, if the only task here was to ask what cosine 2x was, so maybe on a test or quiz, I don't ask sine 2x, I don't ask tangent 2x, I just ask cosine 2x. And I tell you cosine x is 5/13. Which one of those blue formulas would you want to use? The middle one, right? The 2 cosine squared x minus 1. Because all you need to evaluate that is the cosine of x, which you have to be 5/13, right? So let's go ahead and use this one. You're not wrong in using any of the other ones, but if I'm going to use the other ones, I have to have that picture, right? Okay, I have to have that 12 if I want to use this one or that one, okay? But using the middle one, we go 2. So cosine x is 5/13. We'll square that, and then we'll remove 1. That removing of the 1, hopefully you see it that, because it's going to be a fraction, okay, between 0 and 1. When I remove 1 from it, that's going to make it negative, right? And that's the sign that we want. So we have 2. This gives me 25 over 169 minus 1. So it's 50 over 169 minus 1. Okay, so that 1 is what? 169 over 169. So now we get 50 minus 169 is negative 119 over 169, right? If I take negative 119 divided by 169, it gives me that negative 0.7 number that the cosine of 134.76 was generating. Is that all right with everyone? Okay. So stop me if you're confused. Stop me if something doesn't make sense. The next task is to find the tangent of 2x. You've got options here. Okay. If I'm going to do tangent of 2x, you can use the formula. Okay. So the formula is generated by taking like tangent of x plus x using the tangent sum difference formula. And what that's going to end up giving me eventually, just to save a little bit of time here, it's going to give me 2 tangent x on top, and then 1 minus tangent squared x on the bottom. You can use that. Now, if I'm going to use that, I think using that is a longer process. There's more algebra involved. You got to have the picture to give you this 12/5. Okay? If I go 2 times 12/5 divided then by 1 minus 12/5 squared, we should be okay. So I get, what, 24/5 there, right? On the bottom, that's going to be 144 over 25, right? And this is going to be 144 over 144. Okay. Oh, sorry. That's dumb. 25 over 25. We did a different problem last class, and I was repeating that for some reason. So excuse me, 24/5 24/5 divided by, this turns out to be, what's that going to give me if I subtract 25 and 144? Negative 119 over 25, right? 25. No, sorry. I'm all over the place. I'm sorry. That is 5. Okay. So 24/5 over negative 119 divided by 25. So now I can multiply by reciprocals, right? So 24 over 5, and we'll multiply by 25 over negative 119. Now some nice things are going to happen here. Those cancel. Leaves me 5, right? Okay. 24 times 5. Okay, it's going to be 0. Carry the 2. It's going to be 120, right? 120 over negative 119. That's the tangent of 2x. Now, look at the 2 that I've circled in blue. Do you see the 120 and the negative 119 in those? Okay, so what we're looking at then is that we could do this way. Tangent, and this is easier. Tangent 2x. Because I already have the sine of 2x, and I already have the cosine of 2x, is simply 120 over 169 divided by negative 119 over 169. What happens with the 169s? Okay, it's because we're multiplying by reciprocals ultimately, right? But then that gives me just to be 120 over 169, and it's negative. 119. Oh my gosh. 119. My fault. Okay. Does that make sense though? Okay. Through all the errors I made. But we can go sine, and that's true no matter what we're doing, guys. If you're looking for half angles, double angles, whatever. Okay. If you have sine of, you want to know tangent of 3x. Well, if you know sine of 3x, cosine of 3x, divide them. That's the quicker way. Okay. Sammy?
So the cosine and tangent can be negative even though it's in quadrant 1. Because isn't everything in quadrant 1 positive?
Well, so here's the thing. That's what we got to think about. So cosine is in quadrant 1, but what do we find? We're finding tangent of 2x, not just tangent of x. Does that make sense? So because, and that I think is important to talk about because of the, and that picture might help. But if I'm doing x, remember x I think we said was like 60, you may remember what that number was? 67-ish? Yeah. Okay, so that number was 67.38. And that's cosine x, right? So that's obviously in the first quadrant. But when I go cosine 2x, that doubles that, right? Tangent 2x or sine 2x doubles that 67. So when I double 67, that now puts me over in the second quadrant, right? And in the second quadrant, remember, all students take calculus. The only one that is positive there is the sine. So that should hopefully make sense with our plus and minuses there for a cosine tangent. Does that make sense? And I think that, guys, that is huge to understand because here with the double angle formulas, they kind of work themselves out that way. They give you the right sign. Today at the end, I'm going to show you the half angle formulas, and they don't work themselves out. We then have to decide with the half angle formulas what plus or minus that we need to take. Okay? And it's all because there's some square roots involved. Okay, so here's another one that they're going to ask you. They might say, let's deal with, let's go cosine of x again is, so it doesn't matter what they start you off with, it's giving you a picture. But let's say cosine of x is 4/5. But cosecant of x is less than 0. Okay? Now, that information that cosine x is less than 0 is the exact same information that quadrant 1 was trying to provide us earlier. Now, this isn't quadrant 1, but it's the same reason, same logic behind why they add that information. Okay? We need to know what quadrant we're in. Now, they imply the quadrant. When they say quadrant 1, it's pretty explicit, right? You know what they're talking about. When they say quadrant 2, you know what they're talking about. When they say cosecant is less than 0, you're not necessarily 100% sure right off the bat what they're talking about. If cosecant is less than 0, what kind of number is that? Negative. And cosecant is the reciprocal of what function? Sine. So where is the sign negative? Okay, 3 and 4. Okay? So that narrows things down, but not real far, because I still have a choice, right? The other piece of information is that cosine is what kind of number? Positive. What quadrant is cosine positive in? Yeah. We're going to be positive here and there, right? Where do they overlap? Fourth quadrant. So that information kind of tied together is implicitly telling me that our angle x is in the fourth quadrant. Okay? The cosine is 4/5. Now the reason that, basically all of this stuff here, and it would determine the quadrant, was just to tell me that 3 has to be what? Negative. And that's it. Okay? So now if I want to find sine of 2x, okay, we're going to come up with 2 sine x, cosine x. So sine of x is negative 3/5. Cosine x is, and now if I multiply that together, I get negative 24/25, right? Okay. Let's do cosine of 2x. Okay, again, doesn't matter which formula you use. Let's do, because we know cosine, let's use that one. So cosine 4/5, right? So we get 2 times 4/5 squared minus 1. 4/5 squared is 16/25. I double that, I get, careful. 32/25. So 32/25 minus then 25/25 would be 7/25. So after a little bit of work, I'll let you evaluate that, but that should be 7/25. Now when I do sine divided by cosine, so tangent of 2x, I'm just going to write sine over cosine, so it would be negative 24/25 divided by 7/25. What am I going to get? Negative 24/7. So there's my tangent 2x. Now, let's talk about how that all kind of pans out in a picture. We said we were dealing with, what was it, cosine is 4/5. Okay, so we'd be looking at the circle x squared plus y squared equals 25. Okay. 4/5 would mean that we're going over 4, that direction, perpendicular there. We'd be intersecting the circle right there, and that's going to give us that segment, which then We're interested ultimately in that angle right there, right? Okay. Now, that is not really what we're talking about. That angle would be a negative 36.87, right? From standard position. So X that they're telling us in the original problem is actually that. So can't I take 360 minus 36.87? And they're talking really about a 300. So X is a 323.13 degree angle, right? Okay. Now, when we find twice that, it'd be 646.26, right? So when we find sine of 2x, we're actually finding sine of 646.26, which if we evaluate that, it gives me 0.96, but it's negative, right? Well, let's think about what we came up with. I just typed in sine, right? Is that what I typed in? Yeah, sine, okay? Look at, bless you. Look at what we did here. Sine is negative 24/25, right? Well, hopefully you see it. That's 0.9. 24/25, multiply both by 4. Don't get 96 on top. Okay? But 24 divided by 25, got to be negative. Gives me that same negative 0.96 that the sine of 646.26 is giving me. Okay? So that's kind of what we're talking about in that double angle, right? Now 646, you kind of think about 646, where is that going to be? Okay? Well, 646 is coterminal with 286, right? 286. Okay, what is this? Is 270, isn't it? So 646 is probably a ray kind of like going through like right there, right? Okay, that's kind of why the y value is pretty close to -1, right? Okay, so it's almost got to be the y-axis. That ray does. So if I find the cosine, doesn't the cosine end up probably being a pretty small number here? It's going to be a positive number, right? Okay, because it's in, and then it's in the fourth quadrant. So if I go cosine of 646.26, or the cosine of 286.26, they're both 0.28, right? But we found it to be the fraction 7/25. We'll multiply both those by 4, and you should get that 0.28, right? Does this make sense to everybody? Okay. And then obviously the same thing's going to happen for the tangent. Okay. But that's what I want you to understand about what's going on when we do these formulas, and we get those answers real fast. So we know the formulas, just plug it in and evaluate, right? I want you to understand what that negative 24/25 represents. I want you to understand what the 7/25 represents. Okay. In the next couple minutes, guys, I want to introduce you to the half angle formulas, or at least one of them, and that might get you kind of working through that 7.3 a little bit further. But just like everything else, so the way that our formulas are structured in our textbook, they're done that way because usually one piggybacks off the one we just talked about. Okay? So cosine 2x equals 2 cosine squared x minus 1. That thing's going to help us come up with our half angle formula. Okay? And ultimately, guys, if we were just to solve this for cosine, it gives us the half angle. Okay? Here's the thing, though. And I'm going to make the substitution. You can make the substitution at the end. I'm going to make it first. If I look at those two things, are they in a 1-to-2 relationship? Yeah. Okay? So if I were to solve for cosine of x, it's going to give me essentially a half angle of cosine 2x. Does that make sense? So here's the approach that I want to take that I think makes more sense to do it first. If we don't know what 2x is, obviously because we don't know what x is. So let's just say 2x is theta. If 2x is theta, what would x be? Theta over 2, right? It's just a redefine. We're not changing anything. We're just redefining our variables. So now when I substitute that stuff in, I'm going to replace the 2x with theta here, so it'd be cosine of theta. And it's going to be 2 cosine squared of theta over 2 minus 1. Do you see now, visually, that cosine squared of theta over 2, that's a half angle? Our argument is being cut in half, right? So let's solve for that cosine of theta over 2. So I have to add 1 to both sides. It's going to be cosine theta plus 1 equals 2 cosine squared theta over 2. Then what? I'm solving for cosine. I have to divide by 2, correct? Okay. So that'll wipe away. Then what do I have to do? I'm trying to solve for cosine. Square root both sides, right? So the cosine half angle formula is going to look like this. Cosine of theta over 2 is equal to plus or minus. So if I take square root, that's going to be plus or minus there. We usually write it as cosine theta plus 1 all over 2. And the plus or minus is then chosen by us by knowing what quadrant theta over 2 is in. Does that make sense? Okay, so if they gave me theta to be 160, theta over 2 would be 80, right? So then I would take cosine of 80 has got to be a positive number, so I'd take the positive version. If they gave me theta to be, 210, okay, and then I take 210 over 2, that gives me 105, right? Well, 105 is in the second quadrant, so the cosine in the second quadrant, we would take the negative. All right? So that's something to think about as we do these. But the question, the purpose of this is to say, okay, if you want to find out what the cosine of 15 degrees is, we already have an approach using difference in sum formulas. And it ends up being radical 2 plus radical 6 over 4. Okay? But we can also come up with the same amount using this idea. Rewrite it as cosine of 30 over 2. And the reason I do that, you don't have to, but I think it makes sense on what theta is going to be, right? Theta is always that numerator, so that when I plug that into my formula, I know what goes right there. People get confused sometimes whether 15 goes there or 30 goes there. That's always twice as big as the angle that you're trying to find. So we'll plug in cosine of 30 plus 1 over 2. Can you evaluate that? Okay, now cosine of 15 is the first quadrant angle, so I know it's going to be the positive version of this radical. Cosine of 30 is radical 3 over 2, right? Plus 1 all over 2. Okay? Now, that's messy, but there are some things that we can do to clean that up, but because we're running out of time, I'm not going to. But I want to prove to you that if we... Let's actually do it in Desmo. It's a little bit easier with their formatting. All right, so let's go. Let's make sure we're in degrees here. If I did cosine of 15, that's what we're trying to see if we get, right? We already did it using the sum difference formulas and found out earlier in the week that it was the same thing as that number, right? Okay. We just found out that it is also the square root of the square root of 3 over 2 plus 1 divided by 2. Same answer, isn't it? Okay, so we can use that logic. Now, this does produce some new points off the unit circle. Okay, because if I take 30 in half, I get 15. I take 60 and a half, I get 30. 90 and a half, I get 45. So all of those are giving me the same thing. Things I already know. If I take 45 and cut that in half, what do I get? 22.5. So now I can use that to come up with the 22.5 multiples across the unit circle. I can also take, because we now know, or we previously knew what the cosine of 15 was, I can find 7.5, right? Cosine 7.5. It, ultimately, what it does is fills in all those halves that you can find, okay? We know 75 off the unit circle. It's also radical 6 plus radical 2 over 4. I guess for the cosine, it'd be radical 6 minus radical 2 over 4, I think. But I can divide that by 2, right? So 75 divided by 2, I can find now that angle measurement off the unit circle. I find its x and y values. The sine function for the half angle is got its exact same derivation, okay? And we'll talk about that first thing tomorrow, and then talk about tangent, go through some problems with that, and then hopefully get into lowering powers and some product rules for some of these things. But basically, guys, as you go through calculus, the number one trigonometric functions and identities that you're going to use are sine squared plus cosine squared equals 1, and all of its kind of respective identities that go with it. Your half angles and your double angles. Okay? Those are the ones that are most prevalent. Those are the ones that are used a lot when we try to integrate functions. We have to use those formulas. The other ones that we're talking about, reducing powers, sum the product to sum, they're true, they're convenient sometimes, but we don't use them a whole lot in a high school or even a college Calc 1 class. Might use them later on in whatever, like engineering or whatever you go into. But for us, they're not all that useful. Keep working on that homework. Like I said, if we need more time.